Let's look at this example. Here, the only thing that we're doing is a horizontal shrink. This is just going to change the period. Since our b is 2, that's going to change our period to pi over 2. Then we're going to take our 5 x values from the tangent function. We're going to do the same thing to each one of those x values. So if we have these 5 x values, we're going to take each one of these and divide by 2. That makes this negative pi over 4. This one would be negative pi over 8. This would still be 0. This would be positive pi over 8, and this would be positive pi over 4. Now these two on the end are where our vertical asymptotes are. This is our midpoint, and these are our quarter and 3/4 points. Now since there are no vertical transformations happening here, there's nothing happening on the outside of our tangent function, that means our y values are going to be the same as what they are up here. The only thing that will change is the x values. So to sketch this, I'm going to draw in my vertical asymptotes at negative pi over 4 and positive pi over 4. And it's good to go ahead and label these. If you're going to label them, write the equation, which means just write the x equals and then the value. Then we've got our midpoint. For a basic tangent function, this is an x-intercept. And we didn't change anything with the y values, so this is still going to be an x-intercept. That means that point is 0, 0. Here's our quarter point. We only changed the x value, we didn't change the y value. So the y value of that is going to be negative 1. That means this is the point negative pi over 8, negative 1. And then for our 3/4 point, that's going to be at a y value of positive 1, which makes that pi over 8, positive 1. Then we can just draw the curve through here, and as we get closer to the vertical asymptotes, it's either going to go down towards negative infinity or up towards infinity as we get close to those vertical asymptotes. Let's try this one. Here we also have a b of 2, so that means our period is going to be pi over 2. Now for cotangent, the asymptotes are at 0 and pi. Those are the endpoints of our full cycle. And then our midpoint is at pi over 2, our quarter point is at pi over 4, and our 3/4 point is at 3 pi over 4. This one's kind of easy to remember because the quarter point is 1/4 of pi and the 3/4 point is 3/4 of pi. We want to take those x values and do the same thing that we did with our period, which is dividing by 2. That leaves this one as a 0. This is pi over 8. This is pi over 4. This is 3 pi over 8, and this is pi over 2. We've got our locations of our two vertical asymptotes here. So now we want to look at what happens to the y values. The only thing we have happening to the y values here is a vertical shrink. For each of these points, we're going to take the original y value and multiply it times 1/2. That means for this one, it would have been a 1. We're going to take that, multiply it times 1/2, which is going to give us 1/2. This one, it would have started out being 0, so that's still 0. This one would have been negative 1. When we multiply it by 1/2, that gives us negative 1/2. So this gives us the 3 points to plot. Now we can draw in our vertical asymptotes. This one happens to be on the y-axis, so this one is really good to just label it. That way it's easy to tell that that's supposed to be a vertical asymptote. And then we have another one at pi over 2. Then we have our midpoint is at pi over 4. And that's actually going to be an x-intercept, so we can label this point as pi over 4, 0. Our quarter point is at pi over 8, 1/2. And our 3/4 point is at 3 pi over 8, negative 1/2. Now we have all the important points in there. We're just going to draw the curve in here. And remember, you can't ever cross a vertical asymptote. You just want to get closer to it and go to infinity or negative infinity as you get closer to it. There's one full cycle of our graph. Let's do one more. This has a few more things going on in it. We're still going to start out the same way. So we want to look at what the period would be. In this one, we don't have a b, so our period is just going to stay as pi. We do have a phase shift though. Since that's minus pi over 4, that means it's going to move it to the right by pi over 4. And we're going to do the same thing with this that we did with our other graphs. If we're moving it to the right, that means for our x values, we're going to take and add pi over 4 to each x value. Since this is a cotangent graph, we would have started out with these x values, 0, pi over 4, pi over 2, 3 pi over 4, and pi. We're going to take each one of these and add pi over 4. That makes this pi over 4. This one would be pi over 2. This would be 3 pi over 4. This would be pi, and this would be 5 pi over 4. Those are our x values. These two on the ends are where our vertical asymptotes are. Now we need to think about the vertical transformations. We've got two things happening here. This is going to give us a reflection across the x-axis, and then this is going to shift our whole graph up by 2. So what's happening to our y values, let's write down what they would have been to start with. For the quarter point, the y value would have been 1, the midpoint would have been 0, and the 3/4 point would have been -1. We're going to take each of these y values, multiply it by -1, and then add 2. So we're doing the same thing that we're doing on the outside of this function. So our new y values, this one, if we multiply this by -1 and add 2, we end up with a +1. So that one didn't actually change. This one we're going to end up with a +2. This one we're going to end up with +3. So if we go back to our vertical asymptotes, those were at pi over 4 and 5 pi over 4. We have one here and one here. Then for our midpoint, the x value is 3 pi over 4, the y value is at 2. That would put it right there. For our quarter point, the x value is pi over 2 and the y value is 1. And then for our 3/4 point, the x value is at pi and the y value is at +3. And now we're just connecting these. Now since we did the reflection across the x-axis, this is going to be the cotangent graph flipped over. So this one, instead of decreasing like our cotangent normally does, it's going to be increasing. Now we're going to try this going backwards. So we're going to look at a graph and figure out an equation that would give us that graph. There are a couple of different ways we can do these. One way that you can do this is start out by looking at whether the graph is decreasing or increasing. If it's decreasing, that means it's a cotangent graph. If it's increasing, that makes it a tangent graph. If you do it that way, then you can do phase shifts. Or you could think of something, for example, if it's decreasing, you could make it a tangent graph that's reflected across the x-axis. But I'm going to do these two just based on whether it's decreasing or increasing. For this one, because it's decreasing as I go from left to right, that means I've got a cotangent function. I want to figure out the period. My two vertical asymptotes are at -pi over 2 and pi over 2. That total distance is pi. That means that the b would be 1. There's no change in the period. Now the other thing I have to look at, if this is the graph of cotangent, normally cotangent goes from 0 to pi. That means that this has actually been shifted to the left by pi over 2 because our vertical asymptote went from 0 to being at -pi over 2. That would give us a phase shift, which would be left pi over 2. That's all of the horizontal transformations. Then if we look at the vertical transformations, we do have our midpoint as an x-intercept, so that means that we don't have any vertical shifts. We're not moving the graph up or down. But if we look at our quarter point and 3/4 points, if we look at the y values, this one is at +2, this one is at -2. Normally those y values would be 1 and -1. So that means that this has been stretched by a factor of 2. From this we can write our equation. Since we've got the vertical stretch, that means we're multiplying by 2 on the outside. Then we have our cotangent function We don't have another number for b, it's just 1. All we're doing is doing a shift to the left by pi over 2, which means in here we add pi over 2. And we didn't have a vertical shift. So that's all for that equation. Now this is one you could graph this on your calculator and check it. Remember, to graph it on your calculator, you'd have to do 1 over tangent. So on your calculator, you could write this as 2 times 1 over the tangent of x plus pi over 2. All right, for this one, I'm also going to treat this one as a cotangent graph since it's decreasing. If I look at my period, I've got one full panel going from 0 to pi over 2. That means my period is pi over 2. That means I would have taken the original period pi and divided it by 2. That means my b has to be 2. Now I do have vertical asymptotes at 0 and pi over 2. That means that there's no phase shift. Then I want to look at my vertical transformations. My midpoint for this one, the y value is at -1. That would mean that my graph was shifted down by 1. Then for my quarter point and my 3/4 point, my quarter point is 1 unit above the midpoint. My 3/4 point is 1 unit below the midpoint. That means that there's no vertical stretch or shrink because that's how these normally are with the y values. They're all within 1 unit of each other. So there's no vertical stretch or shrink, but there is a vertical shift, and that just took each one of those y values and moved it down 1. So we're moving the entire graph down by 1. That gives us the equation cotangent of 2x, since we said our b was 2, and then we're subtracting a 1 on the outside to get that vertical shift.